In this video, I'll show you a few examples of a bunch of resistors connected together and how we can simplify them using the series parallel connection that we know by now. So in this first example, I'm presented with a circuit that has a bunch of resistors. Actually, it's not a circuit, it's just simple part of a circuit. Why it's not a circuit? Because I don't see any sources. But anyway, so what I'm presented with is 1, 2, 3, 4, 5 resistors connected together, and I'm asked to find the R equivalent or RAB seen from this port, from point A and point B, or port A and port B. So we have to identify which circuits or which resistors are connected in parallel, which are connected in series. And as we have seen before, well, R6 and R4 are not parallel now, because just because they're drawn in parallel, they're not in parallel. They do share this node. This is shared between the 6 and the 4, but this is not a node of 4, actually, because we have the 2 kilo ohms in here. However, if you pay attention, you will see that simply I have this node in here and this node in here, which I actually can draw it that way, is actually shared between the R3 and the R6. So the 6 and 3 are actually connected together. So we can redraw this circuit this way. So we have this 1 kilo ohm in here, and we have this node in here. We have the 2 kilo ohms. Okay, and then we can substitute it. Well, before we do that, we have the 4 kilo ohms in here, and of course we have A and we have B from here, and we're still looking for RAB. So what do we do with that? So combining two resistors, if they're in parallel, simply the way you draw it, it's up to you how you draw it, but typically the approach I take is like, I'll take one of them and I'll just use it to draw, like basically if 3 and 6 are in parallel, I can just basically draw something similar to the 6 or the 3, either way is fine. And then, for example, I drew something like the 6 and I remove the other one, and this is simply 6 in parallel with the 3 kilo ohms, which is simply 6 times 3 divided by 6 plus 3. This is because there are 2. I know how to do this very quickly, which is 19 or 18 divided by 9. This is 2 kilo ohms. So now we can take a look at this resulting circuit. We'll see that this resistor in here is now in series with the 2 kilo ohms, because they have this node that they share between each other, and that's about it. Nothing shares it with them. So we can combine them, so it becomes 2 and 2. Okay, so there you go. So we draw this circuit one more time. So we have 1 kilo ohms in here, and then we have 2 and 2. Well, we have the 4 kilo ohm in here, and then we have the A, we have the B, and we're still looking for RAB. And now the way we do it is I'll pick up one of the resistors and I remove the other one, and I'll just replace it with the equivalent resistor. That's simply 2 plus 2, which is just simply 4 kilo ohms. All right, now we take a look at this resistor, or the one that we have. We have now this and that. They do share this node and they do share this node. So they are connected in parallel, and they're specifically 4 kilo ohm connected with 4 kilo ohm. And because they're exactly the same, I know that the equivalent in here is just simply half of it. So what I have is I have 1 kilo ohm in here, and I have a resistor that is basically the replacement of both 4 in parallel with 4. You can substitute by saying it's 4 times 4 divided by 4 plus 4, but I know that the answer is just half of that because they are equivalent, because 4 in parallel with 4 is simply 2 kilo ohms. All right, so simply the RAB now, the last circuit in here, or the last replacement, RAB that is seen between the B and the A is simply, well, 1 plus 4, or 1 plus 2, sorry, which is 3 kilo ohms, because we have 2 and then we have the 1, and they share one node and they're in series. So I was able to replace all of these resistors with just a simple resistor in here, and that simple resistor happened to have like 3 kilo ohms. That's basically it. It's the same effect as connecting all these resistors together. All right, another example, there's similar. So in here I have another circuit, or another part of a circuit, because there are no sources, and I'm asked to figure out what RAB, basically the resistance that is seen from terminal A to terminal B, or port A to port B. And we'll have to identify resistors connected in series and parallel. So of course, a few of the common mistakes, 2 and the 6 are not in series because they share this particular node is shared with the 2, so they're not in series. If you take a look at, for example, the 12 and the 4, they're not in parallel. Yes, they do share this node, but they don't share this node in here because I have the 2 kilo ohms. And going along with these type of analysis, and after experience, you realize, you know what, the 6 and the 12 simply share this node, and they share this node in here. This is one node. So 6 and 12 happen to be in parallel. Okay, so we're going to redraw the circuit with using that particular fact. Okay, so we have this one is A, okay, and then we have the 12 kilo ohms in here, and we have the 2 kilo ohms, and we have the 4 kilo ohms, and of course we have still the 12 and the 6. So how do we do this? Again, the way I do that is by replacing the 6 by removing one of them and keeping the other. For example, you can remove the 12 and keep the 6 or something like that. Like this is how we do it. I'll just basically redraw it as, instead of the 6 in here, okay, and I have this node, and of course this still the same. Again, what I did is I basically removed this and I kept the 6 kilo ohms, and I know that this particular resistor, the new one, is simply 6 in parallel with 12, which is simply 4 kilo ohms. All right, moving on. So what we have in here is now we have this resistor and this resistors. They share one node and nobody shares this node with them. So they're in parallel, or actually in series, sorry. So we can redraw that circuit. Of course, this is here is A and this is here is B, and that will become RAB. So we could redraw that circuit in here so that we have the 12 kilo ohms. And of course, this one here is just a replacement of one of them. Again, you can pick up one of them, for example, this or that, and just draw one resistor instead. Okay, here. Of course, we have the 4, and we have A, we have B. This is 4 kilo ohms, and this node is still connected to here. All right, and this is simply 2 plus 4, which is simply 6 kilo ohms in here. All right, so now the lesson here, you should be able to recognize by now that this node in here and this node in here is shared between this resistor and this resistor. And frankly speaking, also the 12 kilo ohm shares them with them. So as it turns out that this one in here and these two are connected in parallel, and this resistor are connected in parallel. And as it turns out that all three of them are connected in parallel because they do share, all of them share a pair of nodes. So this node is shared between this, that, and this. And this node in here is shared between the 12 kilo ohms, the 6 kilo ohms, and the 4 kilo ohms. So this circuit is pretty much, or these combinations of resistors can simply be 12 in parallel with the 6, in parallel with the 4, and that becomes the RAB. And the way we compute that is simply, well, the 1 over the R equivalent, or RAB, is simply 1 divided by 12 plus 1 divided by 6 plus 1 divided by 4, and then you can figure out what RAB is, which is simply 2 kilo ohms. So I was able to replace these combinations of circuits with just a simple 2 kilo ohm resistor. Moving on to another example. In this example, we have these combinations of resistors. We have a 6 and a 6 and a 2 and a 6 in here, and we're asked to find the RAB again. And in here, we should be able to recognize that, well, the 6 and the 2 are not in series because they share this with that particular 6 kilo ohms, so that doesn't work. However, if you pay a little bit more attention to it, you will see that this 6 in here shares it with this particular node. So this 6 in here shares this node with this particular 6 kilo ohms, and they also share it in here. And this node as well is shared with this 6 kilo ohms and this particular 6 kilo ohms. So these three resistors are actually connected in parallel. So what do we do with the 2 kilo ohms? Well, let's take a look at it. Is it in parallel with any of them? Well, it does share one node with the 6 kilo ohms, but the other one doesn't share it with it. And so it does share this node with this 6 kilo ohm, but it doesn't share the other node with it. So it's not connected in parallel with any of them. But what we do pay attention to is the following, that one node is actually simply connected to the other node of the same resistor. And we should know by now that the R in here is just simply 0. I'm just going to write it out. The R of a wire is just simply 0. So this 2 kilo ohms is in parallel with a wire, or is in parallel with a 0. And we can identify that 2 in parallel with a 0 is simply 2 times 0 divided by 2 plus 0, which is just simply 0 ohm. So what's happening in here? Well, what's happening in here is simply this resistor has been shorted out. So this resistor is sort of useless because I connected one port to the other port. So in any way, when a current is actually trying to flow in here, it will see, well, there's some sort of resistance in here, but there's no resistance. So what it will do is it'll simply just choose this path in here and just continue. So we'll just ignore that. So this resistor is shorted out. So it doesn't exist. So we can just simply remove it. I can redraw the circuit in here, and if I do that, it will simply appear like this. We have the A, okay, we have the 6 kilo ohms in here, we have another 6 kilo ohms in here, and we have another 6 kilo ohms in here, and this one in here, I can redraw it as a wire because I just recognize that it's just a wire, and I can just connect these in here, and you should be able to see at this point that this 6 kilo ohms is in parallel with this 6 kilo ohms, and it's in parallel with this 6 kilo ohms. So I have A and this is B. So simply RAB is just simply 6 in parallel with the 6 in parallel with the 6. So there's multiple ways to actually compute this particular combination. You can just simply say, well, 1 over RAB is simply 1 over 6 plus 1 over 6 plus 1 over 6. And you can just compute what the value of RAB is. Another way to do it, if you just know, well, I know that this and this are in parallel, so I can combine 6 and 6, and I know because they're exactly equivalent, so that's a 3. So that's also equivalent to saying, well, this is simply just 6 in parallel with the 6 and 6, which is a 3, and you can compute that and I know that this is simply 6 times 3 divided by 6 plus 3, which is simply 2 kilo ohms. Again, what I did in this last step in here is, instead of me just computing the actual generic rule for computing the equivalent resistance of parallel connected resistors more than 2, what I did is I combined 2 at a time. So what I did is I combined the 6 and 6, well, it doesn't matter, this 6 and 6 together, and I just said, well, I know that 6 and 6 in parallel is simple, it's just half, which is 3. And then what I did is I computed 6 and 3 in here that are in parallel, and I know the rule for that is 6 times 3 divided by 6 plus 3. Well, 6 times 3 is 18, divided by 9 is just simply 2 kilo ohms. So I was able to do it in my head.